Hello, my name is Jelena. I'm from Nano Lab, that is laboratory for biomedical engineering in Serbia. In our lab, we're interested in water at nano level. Actually, we're interested in interaction between nanomaterials and water. Why nano? Because as Richard Feynman said, there are lots of places at the bottom. Actually, in our world, we have really lots of available surface. And we know when you have surface, especially if it's hydrophilic, you have very interesting properties of this interfacial water. So we wanted to look deeper into this. Motivation for my poster, for my research, I found in this paper written by Ukrainian group led by Professor Andrievsky. And it was about this particular nanomaterial, actually class of nanomaterial called fullerene. And they have really interesting findings about aqueous solutions of this nanomaterial. What was so peculiar about their findings? Well, they found that actually OH removing efficacy in vitro and radioprotective effect in vivo of these solutions were actually in inverse correlation with the concentration of fullerene, which is quite weird. So they had to actually explain how is it possible that actually this removing efficacy of free radicals exceed the theoretically possible. So they scratched their heads and they realized that in these solutions actually what is in direct correlation is amount of water. So water amount increases. And they came up with two hypotheses to explain this behavior of water solutions of fullerene. They actually proposed that around this nanomaterial, exclusion zone forms. And this exclusion zone water is actually responsible for neutralization of free radicals, because free radicals have these hydrated shells, which are easier to recombine with this water in exclusion zone. And when it comes to radioprotective effect, due to the low mobility of water in exclusion zone, they cannot migrate easily from the loci of their creation. So these were two hypotheses, and they just proposed that as a possible solution, but they did not know how to prove it. And that is where actually I thought of something, because we have a really good method in our lab, near-infrared spectroscopy. And what we wanted, we took actually best friend of fullerene. It is fullerol. It is a derivative of fullerene, which is hydrophilic. Actually, it has only OH groups attached, so it is water soluble. We used it in only one concentration. We took 50 micrograms per liter. And actually, when I said about available surface, this concentration allows you to have actually a surface of this nanomaterial which can be equal to 2 tennis courts. So it is really amazing space for chemical reactions or possibly some other mechanisms of action. So I mentioned we use near-infrared spectroscopy because we think it's really the best possible method to inquire about water organization, especially the new approach called aquaphotomics, which you heard about yesterday from Professor Zenko. So we performed 2 experiments. We wanted to do a structural characterization of water using near-infrared for the exclusion zone water. So we took Nafion because we knew it is a very strong exclusion zone creator, and we took the spectra of such system. And we wanted to compare the spectral signature of such water with the spectral signature of fullerene solutions. More about this first experiment about water next to Nafion, you can see a poster which my colleague actually did. The poster is titled Increased Hydrogen Bonding in Exclusion Zone Water. And what we had in results, these are 2 aquagrams which show that we have equal spectral pattern of water for exclusion zone water and for this fullerene water solution. So what we think that this proves is that we have the same type of water. This nanomaterial acts as a structure maker, so we basically have the same liquid crystalline water as in exclusion zone next to Nafion. And this implies that fullerenes, a class of fullerenes, are not typical radical scavenger, that actually water plays dominant role in their antioxidant activity. That would be all. Thank you very much for your attention.